Okay, Geometry Chapter 5. We are in Section 7, the Pythagorean Theorem. Pause the video and come back and check your answers. Classifying each triangle by its angle measures 80, 70, so we must have a 30, so this would be a acute triangle. We have a 40, 50, 90, this must be a, with that 90 we know it's a right triangle. Simplify this expression. 2 squared would be 4. The square root of 3 squared would be 3, so 4 times 3 is 12. Good. And if a equals 6, b equals 7, c equals 12, find those values. Which value is greater? Well, that's not a hard question. The 144. Oh, I see. A squared plus b squared, so we've got 36 plus 49, or 85. So 144 is greater, c squared is greater. Okay, so in this chapter we are going to use a Pythagorean theorem and its converse to solve problems. We'll use Pythagorean inequalities to classify triangles. So we have discussed many times the Pythagorean theorem. It is such the famous mathematical relationship. So as you learned in 1-6, it states that in a right triangle, the sum of the squares of the length of the legs equals the square of the length of the hypotenuse. Good. A squared plus b squared equals c squared. Find the value of x. Give your answer in simplest radical form. So the unknown in this triangle is which side? You got it, it is the hypotenuse, C. So we will simply substitute, right? And 2 squared plus 6 squared is equal to the hypotenuse squared. So we have 40 equals x squared. Are there any perfects? Oh, we're going to take the square root, right? We're going to take the square root of both sides. And when we do, are there any perfect square factors in 40? Right away we see 4 times 10, right? So pull out the square root of 4, which is, good, 2. And then the square root of 10, are there any perfect square factors? No. So we will have 2 times the square root of 10. The reasoning is, of course, that we have a right angle, so we have a right triangle, therefore we may use the Pythagorean theorem, and then we just substituted, right? And then we simplified, and we used our inverse operation here. We used taking the square root, finding the positive root, and simplifying the radical. Okay, if you need to pause the video, do that. Make sure you understand the reasoning. Finding the value of x, give your answer in simplest radical form. So in this case, we have an expression for one leg, and we have x as the hypotenuse. So once again, we can use a squared plus b squared equals c squared. Due to the right angle, we know we have a right triangle. We can use the Pythagorean theorem. So now when we substitute, we have a binomial for one of the legs, right? X minus 2. So we will square x minus 2 plus 4 squared equals x squared. That's just our substitution, right? So can you square that binomial? Remember how? If you don't remember, multiply x minus 2 times another x minus 2. Hopefully you remember that we end up with a perfect square trinomial. X squared minus 2 times AB, so that would be 4x, right? Plus b squared, which is 4. Good, x squared minus 4x plus 4, that's our square of a binomial, plus 16. We simply simplify this, right? And we end up with negative 4x. And in this step, we combined 4 plus 16. Notice that we subtracted x squared from both sides, So now we're just going to simply find the value of x, which is, subtract 20, divide, we end up with 5. Good. So 5 minus 2, we have 3, and we have the familiar 3, 4, 5 right triangle. Okay, let's apply this in a real-world example. Randy is building a rectangular picture frame. He wants the ratio of the length to the width to be 3 to 1, and the diagonal to be 12 centimeters. How wide should the frame be? Round to the nearest tenth of a centimeter. So if we have this ratio of the length to width of 3 to 1, we could say the following. We could say that the length is longer, right? It's 3 to 1. So the length equals 3 times the width, right? The length equals 3 times the width. 3 equals 3 times 1, right? So we can substitute when we need to, using L equals 3W. Okay, so what will we do with that? We know that we are dealing with a right triangle because this is a rectangular picture frame, and so the diagonal of that picture frame is 12 centimeters. So we'll use a squared plus b squared equals c squared, the Pythagorean theorem. It's a rectangular frame, so we know we have right angles. And we can substitute 3w squared plus w squared. So we have length squared plus width squared equals that diagonal, the hypotenuse squared, right? This is substitution. Okay, we're going to simply simplify this. So 3w squared is 9w squared plus w squared. 10w squared equals 144. Good. And now what will we do next? You got it, divide by 10. There we go. And we now have our w squared isolated. So what can we do? Take the square root of both sides. Good. And we have w equals the square root of 144 over 10. Okay, and so that would be, let's see, about the square root of 14.4, right? If we go ahead and divide this. And so 14.4 is between 9 and 16, closer to 16, and so we have this approximate value to the 10th. We could use FDAD to find that. Very good. A set of 3 non-zero whole numbers, they're non-zero whole numbers, so like the blue numbers on our number line in the classroom, a, b, and c, such that a squared plus b squared equals c squared. There's our what theorem? We got it. These are the Pythagorean triple. When you have a, b, and c such that a squared plus b squared equals c squared, it's a Pythagorean triple. We have some very familiar Pythagorean triples. We just mentioned one in a previous example. So this is a little set of common Pythagorean triples. 3, 4, 5 is the one we mentioned earlier. The next one up from that is the 5, 12, 13 Pythagorean triple. We also have the 8, 15, 17, and finally the 7, 24, 25. So look for these relationships and come to know them the way you do the 3, 4, 5, because that can help you arrive at an answer very quickly when you notice that you have something like 5, 12, then the hypotenuse would be 13. Okay, find the missing side length and tell if the side lengths form a Pythagorean triple. Pause the video and come back and see compare your answer to what you see here. Okay, so here we start with the Pythagorean theorem. Because we have this right angle, we know this is a right triangle. Substitute known values, right? And simply solve, right? And when we take the square root, we find that c equals 50. Okay, so a it could be 14, b 48, and c 50. Because these are all positive whole numbers, we can say that they form a Pythagorean triple. They are non-zero whole numbers that satisfy the equation a squared plus b squared equals c squared. Okay, try it again, pause the video, come back and check out your answer. And here you are back, so let's see. We have 8 squared plus 10 squared equals c squared. So we have 164, right, equals c squared. When we take the square root, we end up with a c, the hypotenuse length, of 2 times the square root of 41. Is this a Pythagorean triple? The answer is no, and that's because the side lengths do not each form a whole number, do they? So due to the hypotenuse length of 2 times the square root of 41, we do not have a Pythagorean triple. The blank of the Pythagorean theorem tells you a way to tell if a triangle is a right triangle when you know the side lengths. So it is the converse of the Pythagorean theorem. The converse is a way for us to look at the sum of the squares of the lengths of the sides. If we find that a squared plus b squared equals c squared, we now can say that the triangle ABC is a right triangle. You can also use side lengths to classify a triangle as acute or obtuse. So this is called the, look at the symbols here. We have a greater than, we have a less than. So this is the Pythagorean inequalities theorem. If c squared is greater than a squared plus b squared, we end up with, as you can see here, what type of triangle? Good, obtuse, right? If c squared is less than the sum of the square of the legs, a squared plus b squared, if c squared is less than that sum, we have an acute triangle. Very interesting, neat relationship. So you could pause the video and check out the next slide here, and this is just a summary of what we've discussed. We have the Pythagorean theorem, where we have a squared plus b squared equals c squared. We have the inequalities, Pythagorean inequalities theorem, which states that when a squared plus b squared is less than c squared, or c squared is greater than the sum of these squares of the legs, we have an obtuse triangle. When c squared is less than the sum of the square of the legs, we have an acute triangle. So go ahead and pause the video and examine the reasoning here. Remember, by the triangle inequality theorem, the sum of any two sides lengths of the triangle is greater than the third side length. Okay? We talked about how two sides have to be able to meet. And so if they are not greater than the length of the third side, they would never be able to meet. So tell if the measures can be the side lengths of a triangle. If so, is this a acute, obtuse, or right? So based on our sums, 12, 17, 15, it looks like this is a triangle. This could work. Okay, so the question is, from here, how do we determine what type? So let's classify it. Let's do this. Let's try our c squared equals a squared plus b squared. And so substitute the known values. The largest side, of course, is the hypotenuse. And when we do, we see that 25 plus 49 is 74. So the hypotenuse is greater than 74, and so this tells us we have an obtuse triangle. Read this and come back and check it out. Okay, I'm sure you've seen that 5 plus 8, the sum of 5 plus 8, 13, is not long enough to allow these three lengths to be a triangle. So this cannot give us a triangle. Okay, pause this, try the quiz, come back and check your answers. Okay, if you're back, the answer for X is 12. Good. With a TV with a 60-inch diagonal, will it fit it? And the answer is yes. Good. explain, we have